Hello students, today we are going to study when there is permutation of like items. Let us see the next question. First question for the day, 22nd question of the chapter. In how many different ways can be the letter of the word Allahabad be arranged? So in this question, the difference is, if you see, A is repeated 4 times, 1, 2, 3, 4. Correct? L is repeated 2 times. That's it. So A is repeated 4 times and L is repeated 2 times. Right? When the letters are repeated, then how you are supposed to calculate permutation? Okay? So the formula will slightly change when the letters are repeating. Okay? Since now whenever we have solved the question, there was no repetition of the letters. Okay, so let's solve this. In word Allahabad, A is repeated 4 times and L is repeated 2 times. Okay, so you know the formula of NPR. The formula for NPR is n factorial divided by n minus r factorial, but when the letters are repeated, this 4 times and 2 times, okay, so in the denominator you will write 4 factorial and 2 factorial. Okay, so there is a slight change in the formula. Instead of writing 4 factorial and 2 factorial, we can name it as P and Q. Okay, so here we can name P is equal to 4 and Q is equal to 2. Okay, so P factorial and Q factorial. You can just name it, or you can just write 2 factorial and 4 factorial in that place. So here, because let us see the number of letters, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 letters and 9 place. So that means N is equal to 9, R is equal to 9, and A is repeated 4 times and L is repeated 2 times. So I am naming it as P and Q. So P is equal to 4 and Q is equal to 2. Right? And this is the formula when there is a repetition of words. Okay, you can just name it. You can name it any letter, P, Q, A, B, C, whatever. Okay, just don't name N and R, that's it. Apart from N and R, you can just name any letter. Okay, so R is also 9, 9P9 here, because there are like numbers. So 9 factorial divide by 9 minus 9 factorial, which is 0 factorial, and 0 factorial is equal to 1. P is 4 and Q is 2. So 4 factorial, 2 factorial. So 9 factorial divided by 0 factorial into 4 factorial into 2 factorial. So 9 factorial can be written as 9 into 8 into 7 into 6 into 5 into 4 factorial. 0 factorial is 1. 4 factorial I can write as it is. 2 factorial is 2. 4 factorial I can just cancel it. Okay, 2 1s are 2, 2 3s are 6. So 9 into 8 into 7 into 3 into 5. So let's calculate that. 9 into 8 into 7 into 3 into 5. It is 7,560 ways. 7,560 ways. Okay. Let's see the next question. How many arrangements can be made of the letters of the word Bharat? In how many of these B and H are never together? Okay. So let us find out when B and H are together. Okay. First of all, let us find the number of ways Bharat can be arranged. So if you see 1, 2, 3, 4, 5, 6, there are 6 letters and 6 places, out of which A is repeated twice, right? So in this case, the formula will be 6 factorial divided by 6 minus 6 factorial 2 factorial, correct? Because A is repeated twice, right? So here NPR is equal to n factorial divided by n minus r factorial and 2 factorial. I will name that as Q. Okay. So Q factorial. So here n is equal to 6, r is equal to 6. Okay, because number of plays is 6 and number of letters are 6. So n is equal to 6, r is equal to 6 and q is equal to 2. Okay, so 6p6 is equal to 6 factorial divided by 6 minus 6 factorial 2 factorial. Okay, so this I can write as 6 into 5 into 4 into 3 into 2 into 1, and 6 minus 6 is 0 factorial multiplied by 2 factorial. 2 factorial is 2, so 0 factorial is 1, 2 you can cut, okay, because 2 factorial is 2 into 1, which is 2. So what is remaining in the numerator? 6 into 5 into 4 into 3. So 6 into 5 into 4 into 3. So it comes to 360. So 360 ways the word Bharat can be written. So this is total possible permutation. Total possible permutation. Okay. So total possible permutation of Bharat, of the word Bharat, is 360 ways. But what we want, in how many ways B and H are never together. Let us find the total number of permutation when B and H are together. Okay. So total arrangements where B and H are together. Okay, when B and H are together, you will consider B and H as one word. Correct? When you consider B and H as one word, if B and H, wait, I'll just erase this. If B and H is one word, then 1, 2, 3, 4, 5. That means now there are 5 letters and 5 places. Okay. So now there are 5 letters and 5 places. You can do 6 minus 2 plus 1, which is 5. Okay. So when B and H are together, now there are 5 places and 5 letters. Okay, because B and H is one letter and A is repeated. Okay, so here the formula will be five P5 is equal to 5 factorial divided by 5 minus 5 factorial. Because A is repeated, so that is 2 factorial. Okay, so total number of arrangements where B and H are together, A is repeated twice, B and H are together, which makes it 5 letters, because the word Bharat, the word P-H-A-R-A-T, so this is one letter, right? And so there are 5 letters, 1, 2, 3, 4, 5. So there are 5 letters, out of which A is repeated. A is repeated, so that is why 2 factorial. Okay. So let's calculate this. 5 into 4 into 3 into 2. This will be 0 factorial into 2. 0 factorial is 1. Okay, 2 factorial is 2. So what is remaining? 5 into 4 into 3. Okay, so 5 into 4 into 3 is 5 into 4 into 3. 5 into 4 into 3 is 60. Okay, so this is 60. But now B and H. Okay, again, when I say B and H, it can be written either B, H, or it can be written H and B. So again, there are 2 ways. Okay, so what we can say is 2P2, because now when we see B and H, it can be written as BH or it can be written as HB. Correct? So that is 2P2. So 2P2 is 2 factorial divided by 2 minus 2 factorial. Here no letters are repeated. It is B and H. The letters are not repeated. Okay. So which is 2 ways. This is 60 ways. So Bharat, where B and H are together, it can be written in 60 into 2 ways. Okay. So total arrangements where B and H are together. So permutation, will be 60 into 2, which is 120 ways. Okay, so total possible permutation is 360 ways, out of which 120 ways B and H are together. That means remaining ways is permutation where B and H are never together. Correct? So let us write the final answer. Total permutation where B and H never come together is equal to total permutation of all letters minus permutation of B and H always together. So 360 minus 120. So 240 ways. Okay. Let us see the next question. In how many ways can letters of the word commerce be arranged? Okay, so here M is repeated twice, C is repeated twice, E is repeated twice. Okay, so the formula here will be, because there is M, E and C, okay, so here I'll write like this. Total number of letters are 1, 2, 3, 4, 5, 6, 7, 8. 8 letters. So N is equal to 8 and the place is also 8, so R is equal to 8. Okay, C is repeated twice. I'll name it as P. So P is equal to 2. Okay, so which is C repeated twice. Okay, P, Q is equal to 2, which is M repeated twice, and I will name it as S. S is equal to 2, which is C, M, E. E repeated twice. Okay, so C, M and E are repeated words. So here the formula will be NPR is equal to N factorial divided by N minus R factorial, P factorial, Q factorial and S factorial. Okay, so 8P8 is equal to 8 factorial divided by 8 minus 8 factorial, 2 factorial, 2 factorial, 2 factorial. 8 minus 8 factorial is 0 factorial, which is 1. Okay, so 8 factorial can be written as 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, and 2 factorial can be written as 2 into 2 into 2, right? So 2 into 2 into 2 is 8, right? So 2 into 2 into 2 is 8. So what is remaining? 7 into 6 into 5 into 4 into 3 into 2. Let's calculate. It comes to 5040 ways. Okay, so 5040 ways. Okay, let's see the next question. In how many ways word finance be arranged? How many of these where F and A always come together? I want you all to solve by your own. Okay. Here there are 1, 2, 3, 4, 5, 6, 7. 7 letters. So N is equal to 7. R is equal to 7. The letter N is repeated twice. So I will name it as P. P is equal to 2. Okay. Why? Because N is repeated. N is repeated twice. So total number of ways. In how many ways the word finance be arranged? So we are solving only this much first. Okay. So total number of ways the letters of the word finance be arranged. So 7p7 is equal to 7 factorial divided by 7 minus 7 factorial 2 factorial. So 7 into 6 into 5 into 4 into 3 into 2. Divide by 0 factorial is 1 into 2 factorial is 2. So what is remaining? 7 into 6 into 5 into 4 into 3. Seven into 6 into 5 into 4 into 3. Just remove this 2. Yeah. Uh-oh. Sorry. 7 into 8. 7 into 6 into 5 into 4 into 3. Which comes to 2520. Okay, now next part of the question, how many of these where F and A always come together? So F and A is always together, so you will consider it as one word. Okay, so yeah. So now N and R will become 6, that's it. N is equal to 6, R is equal to 6. Number of ways letters of word finance be arranged where F and A always come together. So F and A is considered as one letter. Okay, so N is equal to 7 minus 2 plus 1, which is 6. Okay, so the permutation will be because N is 6, R is also equal to 6, r is also equal to 6 and n is repeated twice. So for this case my answer will be, I will name it as P. So P is 2. Okay. So here my answer will be 6 factorial divided by 6 minus 6 factorial into 2 factorial, because n is repeated twice. Okay, multiplied by, because f and a can be written as either fa or af, so two ways. So multiplied by 2. Okay, I am multiplying it right now itself. So, or you can see this thing, you can do it later, or you can multiply it multiply it first only. So wait, we have done this, no? This two ways in this problem, question number 23. Okay, we did 5p5 and then we did 2p2 and then we multiplied it, right? We multiplied 5p5 and 2p2, correct? So what I am doing, here is this is 6p6 and this is 2p2. Okay, I'll write here 6p6 multiplied by 2p2. 6p6 will be 6 factorial divided by 6 minus 6 factorial, 2 factorial. 2 factorial because n is repeated twice, and 2p2 is 2 factorial, 2 ways. Okay, wait, I'll write it properly. So answer is 6p6 multiplied by 2p2. 2p2 because fa can be written as fa and af. Okay, 6p6 because n is equal to 6, r is equal to 6 and p is equal to, instead of p I'll write q. Okay, q is equal to 2. Okay, so 6 factorial divided by 6 minus 6 factorial into 2 factorial into 2p2. 2 factorial divided by 2 minus 2 factorial. Here nothing is repeated, so 6 into 5 into 4 into 3 into 2 divided by 0 factorial is 1, so and 2 factorial is 2. 2 factorial divided by 2 minus 2 factorial is 2. So 2 I can cancel. So what is remaining? 6 into 5 into 4 into 3 into 2 is remaining, which comes to 720 ways, I think. Let's see. ways. Okay, if you are not comfortable doing this way, you calculate 6p6 and then you calculate 2p2 and then you multiply. Okay, no problem. So answer is 720 ways. Okay, so now we will be solving circular permutation. In case of circular permutation, okay, so let me explain you all first. circular permutation. Okay, when there are suppose 5 people and 5 places, 1 2 3 4 5. Okay, the people are A, B, C, D and E. Now there are A, B, C and D. When I ask you to find out the permutation, what you will do? In how many ways they can sit? Okay, when they are sitting in a row, they can sit, this is 5p5. So 5p5. So 5 factorial divided by 5 minus 5 factorial. Correct? This is the answer because there are 5 people and there are 5 places. Right? This is when they are sitting in one row. This is how you solve it. But same 5 people if they are in circular table. Okay, like this A, B, C, D, E. So here there is no start point or end point. Okay, it is a circle. Here this is the start and this is the end when you are writing in a row. So whenever people are sitting in a circular portion, your n is always -1. Okay, for example, here when you are writing in a row, there are 5 people, 1 2 3 4 5. So your n is equal to 5, right? But when they are sitting in a circular motion, okay, your n is 5 minus 1 because there is no starting point when you are sitting in a circular table. So A, B, C, D, E. There are 5 people, correct? But your n is 5 minus 1 when you are sitting in a circular table. Okay? So circular permutation of 5 people when they are sitting in a circle, it will be 4 factorial. Correct? Now when 5 people are sitting in a row, then the permutation is 5p5, which is 5 factorial, correct? Because 5 minus 5 factorial is 0 factorial and 0 factorial is nothing but 1. So 5p5 is equal to 5 factorial, correct? But when people are sitting in circle, then the answer is 4 factorial and not 5 factorial. Okay, so if there are 5 people, your n will be 5 minus 1. I mean, you have to do n minus 1. Sorry, you don't write it like this. You can write it n minus 1. Okay, n minus 1 factorial. Now here there are 5 people, so 5 minus 1 factorial, which is 4 factorial. Okay, this is how you solve when it is a circular permutation. You have to always subtract 1 because there is no starting point or end point. Okay, so let us see the first question. In how many ways 5 boys and 5 girls sit around a table? Okay, if there is no restriction and no 2 girls sit side by side. Okay, firstly let's solve the first part. If there is no restriction, that means there are 5 boys and 5 girls. Total there are 10 people. When there are 10 people, that means n is equal to 10. So they are sitting in a round table, so that means your answer is 9 factorial. Okay, so first part of the answer, there is no restriction. That means there are 5 boys and 5 girls sitting in a circle. So total there are 10 people, right? So 5 boys and 5 girls put together people. Now there are 10 people. So circular permutation of 10 people circular permutation of 10 people will be n minus 1 factorial, which is 10 minus 1 factorial, which is 9 factorial. When there are 10 people sitting in a circle, so answer will be 10 minus 1 factorial, so 9 factorial. And 9 factorial is equal to 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So let's solve this. Nine into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. It comes to 3,62,880 ways. There are 10 people, so answer is 9 factorial because they are sitting in a circle. So 3,62,880 ways. So answer is 3,62,880 ways. Okay. Now let us see they are saying no two girls can sit side by side. Okay. Second part. Now girls and boys are sitting in a round table. Okay. Girl and girl cannot sit together. Okay. So that means when there is a girl, beside a girl there has to be a boy. Okay. Then again there can be a girl, then boy, then girl, boy. 1 2 3 4 5. 1 2 3 4 5. Okay. Now there are 5 girls and 5 boys sitting in a circular motion, circular table. Okay. No two girls are sitting side by side, right? So two girls cannot sit side by side. 5 boys are arranged in a round table. So number of ways in which they can sit will be, I'll just write here, when no two girls sit side by side. Okay. Arrange 5 boys first. Arrange 5 boys. You can arrange 5 girls also first, no problem. Arrange 5 boys around the table. So number of ways will be 5 minus 1 because 5 boys are sitting in a circle. Okay, we are taking 5 boys first. They are sitting in a circle. Okay, so 5 factorial, no, 5 minus 1 factorial. So number of ways will be 5 minus 1 factorial. Okay, so which is 4 factorial. Okay, 4 factorial is 4 into 3 into 2, which comes to 24 ways. Right? So boys, there are 24 ways. Now, after boys sit, okay, now they are sitting in a circle. One boy, one space empty for a girl. Another boy, one space empty for a girl. Another boy, one space empty for a girl. Another boy, and one space empty for a girl. 1, 2, 3, 4. Okay, another boy and one more space empty for a girl. Now there are 5 places empty for a girl. Okay, because now there are 5 places created for a girl. Okay, so that's 5. It can be 5 factorial ways. Okay, boys are sitting where there is no end. Girls are also sitting in a round, but you have already subtracted -1, so you will not subtract -1 again. Okay, so for boys there is 4 factorial ways because there is no starting point. Okay, so now for girl 5 places created. So number of position created is 5. After boys sit, now there are 5 places created. So it can be done in 5 factorial ways. You will not do -1 again. For boys you have subtracted -1. For girl you will not subtract -1 again. Okay. So 5 factorial is 5 into 4 into 3 into 2 into 1. Okay. So which is, when you do 5 into 4 into 3 into 2 into 1, it comes to 120 ways. So total permutation will be 4 factorial into 5 factorial. Okay, 4 factorial for boys, 5 factorial for girls, because we are making boys sit first in a circular motion. Okay, so there are 5 boys sitting in a circular motion, so you will do -1, so 4 factorial. Girls will be sitting in the remaining place. The 5 position is created. 5 place is created for girls. So you will not do -1 again. Okay, which is 24 into 120 ways. When you do 24 into 120, it comes to 2880 ways. Okay. Now let's see the last question of permutation. In how many ways 12 lecturers including the principal occupy the seat around a round table if one seat is to be reserved for the principal? Okay. Now they are sitting in a round table. One place is for the principal, One place is for the principal, this is reserved. Okay. So for the principal, the seat is already arranged. Right? Already fixed. Okay. Now this is already fixed. So remaining there are 11 lecturers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are the lecturers. Okay. Now here what has happened, though they are sitting in a circular motion, principal is already sitting in one place. Okay. So 11 seats are remaining. Correct? So total there are 12 see, in how many ways 12 lecturers including the principal. That means there are 12 people and one of which is a principal. Okay. Even principal is also a lecturer. Right. So there are 12 lecturers. Okay. One lecturer is the principal. So one place is already fixed for him. So how many places created? 11 places created. So here the answer is 11 factorial. So one seat is reserved for the principal. So principal is not moving and remaining 11 lecturers are there sitting in the circular motion. Okay, so this 11th place is already created for them. Okay, so number of arrangements will be 11 factorial. So principal is sitting, and now there are 11 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 place and 11 lecturer. They can sit in 11 factorial ways. Okay. So 11 factorial is 11 into 10 into 9 into 8 into so on. So let's calculate that. 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. It comes to 3 crore 99 lakh 16,800 ways. So 3 crore 99 lakhs 16,800 ways is the answer. And with this we complete permutation. From the next class we will be doing combination. That's it for the day, students. Have a great day. Thank you very much.